Okay, I just wanted to make one video where we used all the different transformations we've covered so far on one trig function, just so we can see how to put them all together. So we're going to graph this one right here. Y equals 3 sine of 3x plus pi plus 4. The first thing we want to do is list out all the transformations. So let's see. We have a 3 out in front. We know that's my amplitude. So the amplitude is 3. We have a plus 4 on the end. We know that shifts it vertically. So that means I'm going to go up 4. Then we said in our last video, on the inside here, we have multiplication and addition. And in order for this to work, we have to factor the coefficient of the x. So kind of separately on the side, we have 3x plus pi. I have to factor the 3 out so that the coefficient of x becomes 1. But if I do that, this was pi. If I factor the 3 out, I get pi over 3. If that's a little confusing, you can always check it with the distributive property. If I distribute 3 times x is 3x, 3 times pi over 3, the 3's cancel and I get pi. So now this is actually what's on the inside, 3 times x plus pi over 3. Now I can isolate both transformations. The 3 changes my period, and we said the trick was take my original period, 2 pi, and divide by what's in front, 3. So my period is now 2 pi over 3. Adding on the inside shifts me horizontally. Addition goes backwards because it's in parentheses. Normally addition goes right, so this will go left. So this is left, pi over 3. Now we have all of our transformations listed out, so we should try to graph it. So let's see. Make this nice and straight as much as possible. And now let's see. We'll start with our x values. Find the 5 key values that you need to graph it. So what's our starting point? Normally sine starts at 0, but I'm shifting pi over 3 to the left. So now I'll start at negative pi over 3. Then I need to find my ending point. We take our period and combine it with my starting point. So maybe over here for scratch work, the period is 2 pi over 3. Then I do minus pi over 3, my starting point. 2 pi over 3 minus pi over 3 is pi over 3. Which means my ending point is a positive pi over 3, which we'll say is, maybe I'll space it out a little bit more. We'll say that's pi over 3 right there. Now, find the middle value. Obviously, the middle between negative pi over 3 and pi over 3 is 0. And then find the last 2 points, the midpoints of these 2 intervals. Using the positive one first. If that's 0 and pi over 3, what's halfway between 0 and pi over 3, or halfway between 0 and 1/3? If you know it, you're good. If not, there's a trick. Double your denominator right here. This is pi over 3. Double the denominator, so multiply top and bottom by 2 to keep the fraction the same. And we'll get 2 pi over 6. 2 times pi is 2 pi, 2 times 3 is 6. Now, if this is 0 and this is 2 pi over 6, what's halfway between 0 and 2 pi over 6? 1 pi over 6. Pi over 6. And now, what's the halfway point here? Halfway between 0 and negative pi over 3? We could do the same trick, but obviously these are mirror images. So if that's positive pi over 6, this is negative pi over 6. Now I have my x values. We'll just write this as 2 pi over 6. One thing I pointed out to my seated class, and I'll point it out to you too, technically these fractions should be reduced, so that should be pi over 3. When you are graphing them out, if you do this trick where you double your denominators to find the midpoints and all that, if you end up with fractions that could be reduced, if you want to reduce them, you can. If you don't reduce them and leave them with all the same denominator, so say pi over 6, 2 pi over 6, and so on, I'm not really going to care. I know you understand how to reduce fractions. The point of this is being able to find the 5 key points. So if you want to leave your common denominator there just so it's more obvious, you can. I'll kind of leave that one up to you. But now let's see. I have my x values, plot my y values. Sine starts at its equilibrium point. Its normal equilibrium is 0, but we went up 4. So now we'll say we're at 4 right here. And as I said before, just label your y values. So that's 4. Sine then goes up to its maximum. If it starts at 4 and the amplitude is 3, its maximum will be up here at 7. So we'll put 7 right here. Then it goes back to its equilibrium, which is 4. So we'll go through 4 right here. Then it goes to its minimum. Let's see, the amplitude is 3, which means if it's at 4 and it goes down 3, it'll go to 1, which we'll say is right here. Then it goes back to equilibrium, which is back to 4, right here. And then, assuming all my dots are correct and I connect them, there we go. There's my nice, neat sine wave. The problems in your book that you will be doing a lot of times only have 1 or 2 transformations in them, but ultimately these are the problems I like to do, where you have 4, 5, 6 different transformations at once, so that you actually have to algebraically find each one separately, and then combine them all in the same problem. So just be aware of that. The problems in your book are generally easier than the problems I like to do, but you just do it step by step. Find your amplitude, factor the inside to find both your period and your phase shift, your horizontal translation, and then find your vertical translation. Plot the x values, find your starting point from the horizontal translation, use the period to find your ending point, and then use this kind of algebra fraction trick to find all the midpoints you need. And then using the vertical shift and the amplitude, find the associated y values, and then just connect the dots and you'll get your nice wave. That's pretty much it for this as far as it goes. If you have any questions on this, feel free to email me or post something in the discussion board. And since I'm assuming all of you are actually watching these, keep in mind I've already uploaded your lab that will be due next Sunday. I figured I'd give you some extra time if you wanted to start working on it over the weekend. Those of you who have already selected a group, I put you in that group on Blackboard so you can work together. I had to shift around a few people to make all the groups even as far as the number of people in them. In those who have not joined a group, I put you in a group just so everything was set up and ready to go. You have no other written homework this weekend because no written homework next week because all the graphing stuff is due on this Sunday night, the 10th. And then you'll have the lab next week that's due the following Sunday, the 17th. And your exam will be posted next Friday. I listed all this on Blackboard, but just so you know, your exam will be posted online next Friday, the 15th, if I'm doing my math correct. And then it'll be due by Sunday night, the 17th, just like your lab will be. If you have any questions, email me, stop by my office, let me know.